Imagine you're cooking a steak. You get distracted, the heat's way too high, and boom, it's completely charred. So what do? Do you start fanning it like crazy, hoping the smoke will just disappear? Or maybe plate it with some fancy herbs? Of course not, right? It's ruined. It's too late. And yet so many companies are doing this exact same thing with their products, setting up checkpoint after checkpoint at the end of the line, trying to inspect the problems away.
Okay, let's really dive into this, because this gets right to the heart of it. The second a defect is created, that time is wasted. That money is lost. It's gone. All you can do at that point is sort the good from the bad, which is an insanely expensive way to run a business. By the time you actually find a defect, you've already paid for the whole thing. And this right here is the main idea of this entire explainer. Listen to this again. Quality is designed. It's manufactured, but it is absolutely not inspected into a product. You just can't add quality at the end. You can't test it into existence. It has to be built in from the very, very beginning. And that's a fundamental shift in thinking that separates the good companies from the truly great ones.
Now, what's so interesting here is the mindset gap this slide really lays bare. The difference between how top-tier experts think and how average employees do. Traditional management is all about catching the culprit, running postmortems, pointing fingers after things go wrong. But Six Sigma, it's all about preventing the incident. It's about designing a system that cuts off the oxygen before there's even a spark to begin with. So how do we actually do this? How do we achieve this preventative mindset? Well, it all starts with a new way of looking at problems, and it's guided by a really simple but incredibly powerful formula. The core concept is something called prevention over detection. And what that means is we have to stop obsessing over the bad results, the symptoms, and we start methodically studying the causes. We don't just stare at the burnt steak and complain about it. We study the temperature, the cooking time, the cut of meat. We focus on the process variables. And this beautifully illustrates that secret formula, y equals a function of x. Your outcome, the y, is always a direct result of your inputs, the x's. And this isn't just some business school concept. It's practically a law of the universe. If you want a different, better outcome, you can't just wish for it. You have to go back and change the inputs. So here's the crucial takeaway from all this. You have to stop acting like the chef who's just fanning the smoke. That's focusing on the why, the outcome. Instead, you need to be the engineer who precisely controls the heat, the pressure, the recipe. That's controlling the X's, the inputs. Because if you get the inputs right, a perfect outcome isn't just likely, it's almost guaranteed. Right, so let's get practical. Let's look at our first real application of this and see how it all builds. If quality really starts with the inputs, then we've got to go all the way upstream, right to the very beginning, the initial design. This is where a strategy like Design for Six Sigma, or DFSS, comes into play. See, quality begins with the design, the recipe. Because, think about it, if your fundamental recipe is flawed from the get-go, it doesn't matter how hard your team works or how diligent your inspectors are. They're basically just picking the best-looking pieces out of a pile of junk. Okay, so we've got a good design, a good recipe, but what about the actual process of making the product? How do we prevent simple, everyday human error from completely ruining our otherwise perfect plan? Well, the answer is a brilliant concept from Japan called poka-yoke, which literally means mistake-proofing. The whole philosophy is just so simple. Don't just hope that people won't make mistakes. That's a losing game. Instead, you make the process itself impossible to fail. You embed prevention right into the DNA of the process. And the wild thing is, once you know what to look for, you see poka-yoke absolutely everywhere. Why do electrical plugs only fit in the socket one way? Why does your car beep like crazy if you leave the headlights on? Or why do you have to press the brake to start the car? These aren't accidents. They are simple, ingenious designs that make the right action easy and the wrong action, well, pretty much impossible. All right, we've talked about designing a good product and building a foolproof process. But let's take it a step further. How do we monitor everything in real time to catch problems before they even have a chance to become defects? This slide shows the huge shift in thinking here. Back-end interception, that's like being a Monday morning quarterback. It's a classic cost center, where you're just paying people to find the problems you already created. But front-end prevention, using tools for monitoring and prediction, that actually adds value by stopping that cost from ever happening in the first place. Now, a key tool for this is something called Statistical Process Control, or SPC.
And the best way to think of it is like a smart thermometer for your process. It's constantly taking the temperature, monitoring all the key variables to see if everything is stable. It's designed to sound an alarm seconds before a failure actually happens.
And here, this is what it looks like in practice. This control chart gives you a live, visual dashboard of your process's health. You can actually see on the chart how, after a change was made, the process not only got better on average, but all that variation, those wild swings, was drastically reduced. The process became stable and, more importantly, predictable. And what about figuring out which of those inputs matter the most? I mean, where do you even start? That's where another powerful tool called Design of Experiments, or DOE, comes in. It's basically a structured way to test your recipe, scientifically changing different ingredients, your X's, to discover exactly which ones have the biggest impact on the final taste, your Y. So let's bring this all home. In a truly high-quality organization, nobody gets a high five for finding a mistake at the end of the line. The real heroes are the people who designed a process where that mistake couldn't even be made in the first place. Just remember this: catching a defect isn't impressive. Not producing one is. Now, this whole prevention-focused mindset is incredibly valuable, which brings us to a final, really interesting question. Why do Six Sigma black belts often earn double or even triple the salary of other people? Is it really just because of a certificate on the wall? Well, in our next explainer, we're going to deconstruct the core career premium of a Six Sigma black belt. See you then!